Okay, so we're continuing with the angle addition laws, but today we're going to be adding solving. We're also going to use the angle addition laws to solve for x. So, first thing we're going to do is review, at least the formulas. Now these are formulas you will need to have memorized come test day. Okay. First one, sine of parentheses a plus b. Now everyone's saying I forgot everything before break, but do you at least remember, is it possible to distribute sine?
Yeah.
No, we cannot. If it was sine of x or sine of a or sine of alpha or theta or beta, then you can distribute. But sine by itself with no variable here, you cannot distribute. All right? Do you guys remember how it expanded? Was sine the friendly one or the snobby one? Do you guys remember?
Friendly.
It was friendly, so it hung out with the cosine. So it was sine A. Obviously, then it would be cosine what? Cosine B. And then same sign or opposite sign? Same. You guys remember more than you think. And then sine, I already used sine of A over here, so this will be sine of B and cosine of A. All right. I'm not going to rewrite the whole thing for the minus. I'm just going to put it down here. If this was a subtraction, what would this change to? A subtraction? Minus, minus. All right. That was the sine formula. Cosine of A plus B. Same concept. You cannot distribute cosine without a variable or an angle there. So we expand it, and when we expand it, is cosine the friendly one or the snobby one? Snobby. And if you have no idea what we're talking about because you weren't here, let me write it out and I'll explain. Cosine A, cosine what? B, same sign or opposite? Opposite, so minus sine of A, sine of B. And again, I'm not going to rewrite it all. If this was minus, this here would be a plus. All right, when we wrote it last week or before break, here it is here. We wrote them all out. When it's plus, when it's minus, when it's plus, when it's minus. But since we already have it in our notes, I'm just writing the shorter version today. All right, so if you weren't here, what we talked about is one way to remember them is first off, sine is the same sign, plus, plus, minus, minus, where cosine is the opposite. So if it's plus, it's minus in the expansion, and if it's minus here, it's plus in the expansion. Sine is friendly, it hangs out with cosine, sine and cosine, sine and cosine. Where we said cosine was snobby, it hangs out with only its own kind, cosine with cosine, and sine with sine. Got it? All right, and the last one, tangent. We had no little trick for tangent other than just know it. Tan of A plus B. We know it's a fraction, and we know at the top, if it's plus here, the top is going to be addition, and the bottom's going to be subtraction. And it's pretty easy when it's addition. What two things are you going to add together? Tan of A plus tan of B. Anybody remember what's at the denominator?
1.
Good job. 1 minus tan A. You guys remember more than you think. 1 minus tan A times tan B. And again, if this had been a minus sign, what would be in the numerator? Minus, and in the denominator, addition. I would not wait until the day before the test to try to memorize these because there's a whole lot more that we have in this unit that we're going to work on memorizing. So start now. Most of you have it already. As I was asking, you had it in your head still. So work on it because, again, we'll be adding to this list as we go through the unit. All right. Are we ready? Okay. Part 2. Angle. Addition laws using A squared plus B squared equals C squared. All right, a sample of what you're going to see in homework tonight. Given sine of u equals 4/5. And there's going to be more information I give you. Before I do you guys agree this is one we're going to have to draw because we don't have 4/5 in our unit circle?
Yeah.
All right. Leave this blank because there will be more information I'm going to give you here in just a second. Cosine of V equals negative 12 over 13. Blank. Number 1, find sine of u plus v. All right, I will definitely need to draw pictures here. How many do I need to draw? 2, 1 for u and 1 for v. All right, so I'm going to draw u here and v here. Sine of u is positive 4/5. Where do I draw it? First quadrant? Is there anywhere else I could draw it? Could it also be the second? Why? Why do we need more information? Because of the all students take calculus is what she said. Sine is positive in these two quadrants. Do you guys see that? So more information is needed. What about for v? Cosine of v is negative. Is cosine negative in only one quadrant or two? So that's what these blanks were for. Do we need more information? Yes. All right, so we're going to fill it in now. U, I'm just going to flat out give it to you. U is in Q1. What does Q1 stand for? Quadrant 1. And V is in Q2. All right, so I'm going to draw U first. Sine of U is 4/5, and U is in quadrant 1. So I'm going to draw it like this. This is U. Okay. Now, they gave us enough information, 4 over 5. Where does the 4 go? Opposite, adjacent, or hypotenuse? Opposite of this angle U, so here. And where does the 5 go? Hypotenuse? Yes? Where are we at? Here, opposite over hypotenuse. Yes or no? Pythagorean's theorem, or this is one you have memorized. What's this leg here? 3. Does everyone see the 3, 4, 5 triangle? Yep. All right. Next one, it tells us specifically where to draw it. Do not let that confuse you and, oh, everything's in quadrant 1. No, they tell you right here where to draw. Okay, Q2, there's V, and cosine is negative 12 over 13. Where does it, I'm going to ignore the negative. Well, actually, we know the hypotenuse is never negative, so that negative will be with the 12. Where does the negative 12 go? Opposite or adjacent? Adjacent. And where does the 13 go? Hypotenuse. Pythagorean's theorem, or that's another special triangle that you have memorized. Anybody have it memorized? Good job. 5, is it a positive 5 or a negative 5? Positive. How many of you knew that in your head? Like I had one person say it out loud. All right, is this one you just had memorized? All right, another way to do it is, let's call that A. A squared plus negative 12 squared equals 13 squared. A squared plus 144 equals, what's 13 squared? 169, and then you subtract what from both sides? 144. And A squared equals what? So A equals 5. And you could have done this same method over here to find this leg if you didn't know that was a 3. All right, and why is 5 positive and not negative? It's going up. Positive direction. All right, got it? So far, so good? Okay, so you do have to pay attention to that, because if this was in quadrant 3, that 5 would be going down and it would be a negative 5. Do you see that? All right. Okay, so now we're coming back to this. Sine of u plus v. Obviously, we've talked about this. We cannot distribute. The only thing we can do is expand. So we're going to use our expansion formulas. Cover the top, if you will, on your own paper, or just don't look up there. The sine formula, friendly or snobby? Friendly. So I know it's going to be sine of u, cosine of v. Same sign or opposite? Same. Plus sine of v and cosine of u. And now what you're going to do is just simply use this picture, these two pictures over and over. So sine of u, which picture am I going to use, the first one or the second one? First, because that's the one that we drew for u. What is sine of u? 4/5. Did we know that already because that was given? Yes, but could we use that from our picture as well? Can we get that? All right, times cosine, I'll go ahead and put parentheses instead, times cosine of v. Which picture will I use, the first one or the second one? V, cosine of v is the second, and cosine is adjacent over hypotenuse, which is negative 12 over 13. Again, given information, but we could use our picture as well. All right, now we're on sine of v. Do I use the first picture again for sine, or now do I go to the second one? Second. All right, sine of v was not given, so we definitely need our picture. What is sine of this picture? 5 over 13. Parentheses, and then cosine of u, this one's u. Cosine's adjacent over hypotenuse. What do I end up with? 3 what? 3/5, 3 over 5. All right, and then you multiply. What's 4 times negative 12? Negative 48. Anyone know what 5 times 13 is? 65. Plus 5 times 3? 15. And again, 13 times 5 is 65. Do they have a common denominator? So can I simply add negative 48 plus 15? And that comes out to be negative or positive? Negative what? 33 over 65. Make sense?
We're able to reduce the
Yes, yes, I do. Her question was, if you're able to reduce, would I like you to reduce? Yes, yes, you do have to reduce when it's possible. All right. Number 2, I'm going to let you try on your own. Find sine of u minus v. Go ahead and do that now. If you haven't done it already, first expand. How is this similar or different from the last one? All right, they said it's the same numbers. There's sine u, cosine v, cosine u. Only thing different is the minus. When you have problems like this, do you have to show all this work again? No, I'm going to just so you can see it, but you do not have to. So did anybody just go straight to here, negative 48 over 65 minus 15 over 65? No? Okay, and we're going to do the whole thing just to get the practice, but I just want to point out when you're doing homework and you're doing a few of these, you can use that shortcut. Now, after this problem, I'm going to stop here. We're going to do a different type. But could I ask for this particular problem as well, find cosine of u plus v, or cosine of u minus v, or tangent of u plus v? Okay, so there's a variety of questions we could ask here. All right, so sine of u, what is sine of u? 4 over 5. Cosine of v, what's cosine adjacent over hypotenuse is what? Negative 12 over 13. Take away sine of v, opposite over hypotenuse. What is it? And then cosine u is what? All right, so that gives me negative 48 over 65. Take away 15 over 65. Same answer as the last one or a different answer? So it comes out to be negative what? Over still 65? All right, questions? Are we good? All right. Part 3, solve. All right, we are going to be solving for x. Same as before, we're going to restrict ourselves to one period, so going around once. 0 is less than or equal to x, which is less than 360. If you land on the 360, should you put 360? No, what do you put instead? 0. Not equal to 360, equal to 0. Just a quick reminder, because I believe the textbook writes it differently. You've seen this notation before. 0, comma 360, like this. Yes, you guys have seen that notation before? Interval notation, do you remember that from last year? What's another way to write it? I'm going to put degrees here. Instead of 0 to 360, it could be 0 to 2 pi. All right, so when you see that notation in the textbook, just remember it's interval notation that you learned last year. All right, number 1. Sine parentheses x plus pi over 4, close parentheses, plus sine parentheses x minus pi over 4, close parentheses, equals negative 1. All right, this is a definite standard homework problem, quiz problem, definite test question. All right, now we've done a few of these. I'm hoping nobody would look at this and say, oh, I'm going to distribute sine of x plus sine of pi over 4. You would get no partial credit if you did that mistake on the test. Got it? All right, what should we be feeling at this point? We've done it so many times since... even before I said equal to 0, we may have to eventually, but what can I do here with well, right there. What should I do with that one? Change it to the formula? Expand it? Expand it? Can we expand each one? Yep. Yes? What was that? Oh, the co-functions? Is that what you guys were asking? Okay, okay. I'm glad that was brought up. I thought it was a complementary co-functions is what, and so that's what you guys were saying cosine. Let's take a quick look at the complementary co-functions. Yes, it is pi over 2 is what she just remembered. it's pi over 2 minus x, because it has to be 90 minus x for the complement. All right, so different type of problem, but I'm glad you guys at least recognize, hey, that looks like the complementary cofunctions. Okay, so expand and expand. All right, so get used to that tonight. If when you're doing these, don't know what do we do again? Expand. If it looks like one that we've been doing where, oh, there's sine in parentheses or cosine in parentheses, don't distribute, expand. All right, so what do I get? Sine of x, sine pi over 4 or cosine pi over 4? Cosine pi over 4 plus or minus, plus, and then sine of what? Pi over 4 and cosine of x. All right, so all of this here is this right here. Okay, plus, now I'm going to expand the second one here. And when I expand this piece, I'm going to, again, it's sine, assign the friendly one or the snobby one. Friendly, so sine of x cosine of pi over 4. Same sign or opposite? Same. Minus sine of pi over 4 cosine of x. All right, equals -1. Okay, a few things going on here. First off, any questions on how we expanded? Does everyone see why it's really big? Because there's two expansions, this one here and this one here. All right. Questions before we move on? All right. Anything cross out? Any like terms? Okay, this one right here. Positive sine of pi over 4 cosine x, negative sine pi over 4 cosine x. Do you guys all agree? All right. Gone and gone. All right. Now this next piece, are these like terms?
Yeah.
Yes. All right. So I can add them together. Add the coefficients. What does that give me? 2 sine x cosine pi over 4 equals -1. There is more than one right answer for the next step, so I'm going to leave it open and see if anybody can make any suggestions. If this was a test question, you got this far, what would any of you do next? Anything. Multiply by the reciprocal. So multiply both sides by 1/2. Is that the same as dividing by 2? Yep. All right, so that's a good idea. Get rid of that 2, the coefficient of 2 in the front. Sine x cosine of pi over 4 equals -1/2 or +1/2? All right. Anyone else? Something should be like screaming at you.
Separate them, so like sin x equals -1/2.
Like set them both equal to -1/2? Good observation. She said, can we split these up and set this equal to -1/2 and that equal to -1/2? Can we do that?
Of course.
What is she thinking of? The what product property? What is it called?
Zero.
Zero product property. Does it equal 0? No, so we cannot. Perfect. Cosine of pi over 4 should be screaming at you. Change me, change me. Is cosine pi over 4 one of our special values on our unit circle? Yes. Pi over 4 is what? 45? What's cosine of pi over 4? Root 2 over 2 or 1 over root 2, up to you and how you write it. Okay, so I'm going to put a little here. You guys said evaluate this. I'm going to write it as 1 over root 2. You're more than welcome to write it as 2 over root 2. All right. So when I write that, I typically write my coefficients out in front. So I'm going to write it like this. 1 over root 2 sine of x equals -1/2. Any of you want to write it as root 2 over 2? Yes? Is root 2 over 2 the same as 1 over root 2? Yeah. All right. Does everybody see how I just simply took this red bubble and brought it to the front? Yes, sine of x is still there, negative 1/2 is still there. Cosine of pi over 4 is root 2 over 2, and I just wrote it in the front so it looks more like how we're used to seeing it. All right, I'm still trying to get sine of x by itself, so what can we multiply both sides by? 2 over root 2. Now, why would we do that? To get sine by itself. Good. Cross out, 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 out. Sine of x equals, can I reduce anything here? The 2's? What does that leave me with? Negative 1 over root 2. Whew. A lot of work, but a definite on the test. Okay, so how many answers here? How many places is sine negative? 2. What's the reference angle first off? 45? Now, is 45 degrees one of the answers? Why not? Because it's negative, meaning it's not in quadrant 1. So what 2 places is sine negative? 3 and 4. So what is 45 degrees in quadrant 3? And what is 45 degrees in quadrant 4? Anybody have them? 2. Here it's bigger than 180, so 200 and what? 25. And here it's between 270 and 360, so 315. Okay. Now, this is new, so you may be thinking, oh, there's no way I can do this on my own. Get the practice on homework tonight, so by the time test day comes, you've got this and you know how to do it. This piece right here is where kids typically get stuck. They forget, hey, I know sine of pi over 4, or cosine of pi over 4, or sine of pi, or pi over 2. It's going to be some special angle that you know, and you can just write it as a coefficient and get rid of it to the other side. Got it? All right. Next one. Number 2. Okay. Tan of pi plus x plus root 2 times cosine of 3 pi over 2 minus x, close parentheses, equals 0. I'm going to put stars around this one. Why would I be putting stars? Not only is it on the test, but it's one that kids typically mess up, struggle with, have difficulties with. All right, ladies, you listening? Okay, similar to the last one, since we did it already, what do you think we're going to do with the tangent and with the cosine? Expand. Good. We're going to use the formula and expand it. Yes? Now, right now we're doing a lot of expanding. Last week or that week before break, we did expanding and condensing. You want to get used to both of them. All right, let's expand the tangent first. What's special about the tangent? It's a what? Fraction. Tan of A, which is pi, same sign, plus tan of x over 1 minus what? Tan pi tan x. Do you want to continue expanding or simplify this piece first? Up to you. It doesn't matter. Continue expanding. I'm going to. Thank you. Now, before I continue, can you guys at least see right away tangent of pi here and tangent of pi here is something we can evaluate later? Right? Is tangent pi something on our unit circle that we could figure out? All right. Okay, I'm going to continue. Root 2. Now, since root 2 is in front of this, what do I need to put here? Parentheses, so I can do what with the root 2 later? I will end up dividing eventually, but what am I going to do here first? Distribute. Do you see that? So we need that root 2 in the root 2 outside of the parentheses to remind us to distribute later. All right, cosine, friendly or snobby? Snob. Cosine of 3 pi over 2 and cosine of what? Cosine of x. Okay, and then minus or plus? Plus, good job. Sine of 3 pi over 2 and sine of x, close parentheses, equals 0. Okay, so just scan through really quick and see which ones can you evaluate. We said these earlier, tan of pi and tan of pi. There should be something everywhere. Like in this first piece, what could we evaluate? Okay, and in the next section here, which one could we evaluate? Sine of 3 pi over 2. All right. Are we good? Okay. Tan of pi. What is tangent of pi? Pi is here, and it's what? -1, 0. And tangent is y over x. So what is it? 0 plus tan of x all over 1 minus tan of pi comes up again. We already calculated that tan of pi is what? 0 times tan of x. All right, so let's clean this up. What's 0 plus tan x? Tan x. What's 0 times tan of x? 0. So 1 minus 0 is 1. Do I need to write that 1 underneath it? No, on the next step I will drop it, but I just want to make sure you see right now tan of x because it's plus 0 and 1 because it's 1 minus 0. Do you see that? All right, plus, do you want to distribute the root 2 now and clean up, or clean up and then distribute? It does not matter. Clean up first? Clean up first, yeah? Okay, root 2, parentheses, 3 pi over 2. 3 pi over 2 is here, yes or no?
Yes.
Okay, so that is 0, -1. What's cosine of 3 pi over 2? 0 times cosine x plus what's sine of 3 pi over 2? -1 times sine of x. Do you guys see how we got the 0 here and the -1 here from the sine and the cosine? Questions? Okay. Plus root 2 parentheses. What's 0 times cosine x? 0. Plus sine x or minus sine x? Minus sine x equals 0. All right, let's clean up further. Tan of x, what does this become here? Any thoughts on how to write this? Is this inside here just going to be sine x or negative sine x? So root 2 times negative sine x. Do you agree? Can we rewrite that then as tan x minus root 2 sine x?
Yeah.
Is that equivalent and easier on the eyes? Because this is the way we're used to seeing it, right? Root 2 times negative sine x is negative root 2 sine x. Yes or no? All right. Not done, but we've gotten as far as we can as far as cleaning everything up. Questions so far? Do you guys see what? Yes. Yes. All right, so what do you think the next step is going to be? Okay, set each piece equal to 0? Okay, I'm going to quickly write down the assignment down here, so we're going to take a quick pause. This is 4-2, yes or no? 6-2, thank you. 6-2, page 382. 49 through 56 and 81 through 84. 49 through 56 and 81 through 84. That's not a whole lot. All right. We're good? Okay, I'm going to continue with this problem. Guys, this problem right here, think back to last unit. Last unit, how did we solve all those tricks to try? Remember those tricks to try, that big list we had? There were like 7 or so on the list. Something we can do here to try to solve this. Change it to sine and cosine. So sine x over cosine x minus root 2 sine x equals 0. All right. Any thoughts? Multiply this by cosine x? Like, to find a common denominator. Okay, 2 choices. Ignore the 0, rewrite this with a common denominator. Or, because it's an equation, we can clear it just like we would a complex fraction. You can clear by multiplying by the common denominator. What would you guys, the easiest way is to clear it. But what would you most likely do if you were faced with this on the test? Would you clear it by multiplying? Or would you common denominator and go through those steps? Clear it? Are we okay with clearing it? Yeah. Okay. So now that we've reviewed, clearing, you clear it just like you would clear a complex fraction. So you multiply everything by what? Cosine x. And why cosine x? Because what's going to happen there on the first fraction? What's going to happen here? It's going to cross out. That's why we multiply by the common denominator. So the common denominators, so they're gone. All right, so I'm left with sine of x, take away root 2 sine of x cosine of x equals 0. All right, we're still back in last unit. Pull out a GCF. Good job. What's our GCF here? Sine x parentheses. This does not disappear. What are we left with there? 1 take away root 2 what? Cosine x. Now can we use the zero product property? Yep, it's multiplication, it's equal to 0. So one of them is going to be sine of x equals 0, and 1 minus root 2 cosine of x equals 0. I'm going to let you guys solve that quickly. Sine of x equals 0 you can do on your own. This you're going to isolate, subtract the 1, divide the negative root 2. All right, what did you guys get for sine of x is 0? Are there 2 places where sine is 0? Yeah, where are they? 0 degrees and 180 degrees. All right, I isolated already. I'm hoping you guys did the same thing. Did you get cosine x equals positive 1 over root 2? Yep, and what's our reference angle there? 45. Is 45 one of the answers? Yes. Why? Because it's positive, which means quadrant 1 is one of our solutions. So where's cosine positive? Quadrant 1 and quadrant 4? And this is the one we go all the way around. So what's quadrant? What's 45 in quadrant 4? 315. And those there are our answers. All right, got it?